And we're talking about modeling variation. And you should recognize a lot of this from Algebra 2. We're talking about two types of variation primarily. We've got direct variation, where as x increases, y also increases. And this is written as y equals some constant times x. K is called our constant of proportionality. So that's the first type. The second type is called indirect. Variation. And as you could guess, as x increases, y decreases. And this is written as y equals to our constant of proportionality over x. You have to divide by it. Okay, and then there's sort of a hybrid between these two, which is what's called joint variation. Where a variable varies with and here we're talking about our dependent variable. Two or more independent variables. And this can look something like y equals kxt, where here now y directly varies, it jointly directly varies with both x and t, or you can set it up as y equals to kx over t, which means it's directly proportional with x, inversely proportional with t. Okay, let's deal with some examples. R is proportional to I, and inversely proportional to P and T. Okay, so I deal with this as several different little problems. So R is proportional to I. So I'll translate each one. R is proportional, means I'm going to have K times I. Now, inversely proportional means these are going to be in the denominator to P and T. And that's how you write that one. Another example. Instructions on this one are going to be a little different. Write an equation the constant of proportionality. In order to find this constant, you're going to need a point. You're going to need numbers at a point. So here's what your problem says. Z varies inversely as t. If t equals 3, then z equals 5. So the first thing we do is we write our equation. All right? I'll come back in. Z varies inversely as t, which means t is going to be on the bottom, and my constant of proportionality is going to be on the top. Okay, now we come in and we find the constant of proportionality. This is what you use. You plug these numbers in. So z is 5, so anywhere I have a z, I put a 5, equals k over, anywhere I have a t, I put a 3. Now I solve for k. Because I'm dividing by 3 here, I'm going to multiply both sides by 3. So k is 15. Okay, now you're still not done yet. You're almost there. We solve for k. Now, plug k into your original equation. So if you remember right, our original equation was z equals kt. K is 15, so I put that in place here. So the answer now becomes z equals 15 over t. And this is the equation we want to work with. Okay, one more example. W is inversely proportional to the square of r. If r equals 6, then w equals 10. And we plug these in. Well, first thing we do is write our equation. We're not ready to plug in yet. So W is inversely proportional. So K, but it's to the square of R, so it's going to be over R squared. And that's it. Now we need to find our constant of proportionality. So we plug these in. So 10 equals K over 6 squared, which equals to K over 36. All right, so my new equation now is 10 equals K over 36. To solve for K, I multiply both sides by 36. And K is 360. And now I plug this in up here. And my final equation becomes W equals 360 over R squared. And that's how you find these equations for variability.